Alright, so today's lesson 8.3 is cosine law. And the learning goal is to use the cosine law to solve for missing sides and for missing angles of any triangle. Okay, the way the cosine law works, similar to yesterday, is that you need to begin with a triangle that is properly labeled according to capital letters for the angles and corresponding sides written with lowercase letters. So A is opposite side A, B is opposite side B, C is opposite side C. And this law is based on segments. So if I were to look only at this part here, you'll notice that A squared equals B squared plus C squared. Assuming I switched around what letters were labeled with what letters, we would basically have Pythagorean. And the reason this works out is that if I were to try the cosine of 93, if you imagine that A was actually an angle, cos 90 on your calculator is 0. So negative 2 times 0 is all 0. So if I tried to use cosine law for a right triangle, I would actually end up with just Pythagorean. So basically, cosine law is Pythagorean theorem that's been skewed slightly. So it's been skewed by this factor. Negative 2 times b times 2 times the cosine of angle. And we can do it for any missing side. In fact, it always has the same structure. The side here, A, matches the angle at the end, A. And then B and C show up again here. And the pattern continues. So in the second one, we have side B, which means you must have angle B at the end. And when we have side C, we must have angle C. So basically, the other two, if I have B here, then the other two have to be labeled A and C that are squared and A and C that are multiplied by negative. Okay, so let's try to use it. Example 1. Determine the length of C to the nearest centimeter. Since I'm looking for side C, I need to write out the equation that starts like this. C squared equals A squared plus B squared minus 2AB cosine. Okay, this works out because I happen to know A and B. Side A, if I label it, across from angle A here. Side B, so A squared is 7 squared. B squared is 5 squared minus 2 times 7 times 5 times the cosine of 43 degrees. Now, all of that can be written one step on your calculator if you do so carefully. You will get 22.8052 approximately. And what you should tell your calculator to do is take the square root of that answer, square root both sides. We will get the approximate length of C, and it says in the question to the nearest centimeter, so we're going to approximate about 5 centimeters. So side C is 5 centimeters. Example 2. You can also use cosine law to find an angle when you have all 3 sides. So in this case, we didn't label, it's not labeled A, B, C. So because we're looking to find angle R, we need to have R at the end. We need to have cos R, which means we need to start with little r. So based on that, replacing the A and B with the letters P and Q, we should be able to write our own formula. So P squared and Q squared minus 2PQ times the cosine of R. So that way we've used all the letters in the right spot. So R squared, we know the value of R squared, 3.2 squared. And then we're going to need P squared. Well, we have that. P is over here, 5.9 squared. And we will need Q squared, and that will be 6.2 squared. So if we write all those values in, R squared goes here, 3.2 squared equals 9 squared plus 2 squared minus 2, 5.9, 6 point cosine of R. capital R becomes our only unknown value. In the next step, you just have to be careful that you're not combining things that cannot be combined. So 3.2 can be a value, 3.2 squared. 10.20. 5.9 squared plus 6.2 squared. These can be combined. So if we type all of that in, we get 73.5. All of these are being multiplied. So to do that, negative 73.16, but they're all being multiplied with cosine r. So imagining this is all a big variable again. Cosine r is a variable. You cannot combine the 73.25 with the 73.16. You can't do the subtraction in the middle. You can't do that because they're not like terms. This one doesn't have a cosine r. The first one doesn't. The second one does have a cosine. So instead, we'll have to move this over to join with the other. It'll be 10.24 minus 7 equals negative 73.16 r, still on the right side of the equation. And subtracting it, negative 3.01. We're just dealing with opposite operations here. Undo the multiplication by dividing. Okay, you'll get a decimal answer. It's positive. 0.861263 approximately. And all we have left on this side, because of the cancellation, is the cosine of r. Now, yesterday in your books, when you were doing this, you're finding a missing angle. You have to use the second function. So you're going to shift or control post the value 0.861263, or just type in the answer key on your calculator, and you get an approximate angle for r to the nearest degree, rounds up to 31 degrees. Okay, and last but not least, a problem. So we need to draw the picture, and we're hoping to get a triangle, otherwise we've set it up incorrectly. So this question deals with north, south, east, west. So just to remind you, never eat shredded wheat, never eat sour watermelon, or whatever you've learned. And we need to draw a picture of a frozen lake. So Sheldon starts from the most westerly point of the lake. So if we start on this side and travels 8 kilometers. So we can make it straight across, we can make it diagonal, it doesn't matter. So I'll make it just to show you, it doesn't have to be straight. 8 kilometers before he turns. I'm going to straighten it up a little just to show you the turning part. Get rid of that. Start with it straight. I'll show you how the turn can be drawn. So 8.0 kilometers. Instead of continuing straight, he turns. And he turns at an angle to the right of 59 degrees. So if he would have kept walking, that would have been straight. For him to go to the right, away from the dotted line, that's where we're going to put our 59 degrees. Okay, and our triangle, so he ends up on the most easterly point of the lake. So this is west, the easterly point. We want to know how wide is the lake across. So if this is the lake, water here, okay, we have a distance we want to know, and I can use this color it in. Okay, so there's the lake. So our triangle, I'm going to redraw it for you, has an 8-kilometer side. There's another 6.1-kilometer side over here. That's the distance you walk. It doesn't have an angle inside the triangle, but there is one outside. So if we use our supplementary rule, 180 minus 59 will give us the angle inside the triangle, 125. Okay, so let me redraw our triangle. So we'll sit. We have 8.0 kilometers. We have 6.1 kilometers. We have a distance we don't know. We have an angle, 121 degrees. And we're going to use cosine law to solve for this. We can label it with west and east if you like. We can label it ABC, doesn't matter. A, B, C. If I set it up like this, we're looking for side B. So we need B squared, A squared plus C squared minus 2AC so that I can end with cos B. And then filling in the values. 8 squared plus 6.1 squared minus 2 times 8 times 6.1 times the cosine of 121 degrees will be B squared, 151.478. And last step, you need to take the square root of both sides and find out the exact length. So, or find out the approximate length, the nearest tenth of a kilometer, 12.3 kilometers. Now, without exactly, or doing all of example 4, I'm just going to explain that normally cosine law has a lot more room for error. So if I use cosine law to find angle J, like we did in the second example, okay, that would be okay. And then I could use it again, do all that work and find angle B. I could use it again and find angle N. However, it's not the most efficient method. So if we did that, we get 3 angles. Hopefully, they should all add up to total sum 180. Okay? What might be more efficient is to begin by using cosine law. So cosine law for angle J. So let's say we know angle J. We know angle J. Well, J and 10 are corresponding. We know little j then and big J. So secondly, if we want, we could choose to use sine law and find, doesn't matter, angles. And once I know J and B, I know that the sum of the angles in a triangle are 180 degrees. So I can do 180 minus angle J minus angle B. And that would give me, find angles. Okay, so that would be more efficient. If you compare your answers, you will get a similar answer, but there's probably a little bit more rounding that happens in each case, so it could be slightly off, but it is more efficient to not use cosine law all 3 times. You should only ever use it once and then switch to a different rule. All right, that's it. See you tomorrow.